Hello everyone, thanks for your coming to this meeting. This session I want to introduce about multi-axis motion control solutions. Multi-axis motion control solution. And my name is James Feng Lee. I'm the manager of the mechatronics control department. And we have provided our motion control solutions. In this session, I want to introduce for you. Okay. In the first slide, I want to show you what's the key part of our solutions. Here you can see, in the traditional mechanical system, if you want to produce, for example, if you want to produce your mobile phone case, your mechanical software engineer, you can use the CAD file, you finish your CAD file. After that, you can do automatically to choose the CAD file. After the CAD file, maybe as you know, in the traditional is generate the GM code, in which your machine can to finish the line trajectory or the CW circle or something else. But in our solution, we have our private library. We can call it the motion control command library. The user can use our library. You can see the example, MCC line, MCC circle, to finish all over the trajectory. What do you need? Okay. And here, this part is our key component. These are our in the mechanical system the part. Okay. The most important, we will focus on thermal command generation. We provide a lot of API for our user to use to meet their need. Maybe the isolation, deisolation, interpolation, to avoid the vibration of a machine, for example. After that, we can send out to the plus command or the voltage command. Voltage command you can say also you can set is the velocity command or the torque command. Send out to the servo driver. Servo driver is a closed control loop. All over this one we can see its controller. And here, maybe someone will call what's controller. Maybe it's a purple block. It's about the controller servo command generation and the servo motor and the servo driver. But here I will show you to let you know we focus on servo command generation. Okay. Next slide, I want to show you over the solution what we provide. You can see the SSS. We can also call it the traditional servo control. You can send out the plus command or the voltage command, or you can use the velocity or torque command. In the YSS, we will let you know we will focus on PC base. Okay, in the Taiwan ITRI, we provide our research and development about a motion control ASIC with a F-shell ASIC. And after that, we will also provide motion control card. It also maybe 4 SS or 6 SS. You have a PCI or PCIe interface. Also. And you can also see the YSS. You can maybe always be used in standalone. Standalone is just need to power on it. Because our third generation is intelligent motion control platform. Okay, it is the IMP3. It has built in the CPU and a high real-time operating system, VxWorks. So it also have a PCIe interface. You can use it in the PC base, or you can just stand alone. But only standalone solution, we also provide IMP6000S. Okay. And in the recent years around the world, maybe like in the digital control, or you can also call it digital servo. It's more and more popular in the industry. And you also can separate to the private protocol, something like a SSCnet or make ProfitNet, something else. But here we provide is public. It's from German. It's a Backhof. It's a ISA-CAD motion control platform. We also focus on the master controller. It's called EMPS. Okay. In the machine, in the industry, a lot of extended input and output module we need also. We also provide in the second generation with F-shell with the S-Limited solution, or IMP3 is our AIO. And our ISA-CAD also have a slave solutions. All over this while we let you know we have provided the product is a finish, is a very good product for a motion control solution. Okay. Next product, will let you know, we have a hardware, we also need to do the software, we need our motion control command library. So integrate together. And MC0 is the most important part because we accumulate more than 20 years. The most important is about trajectory planning. In the CNC, maybe you can call it point to point, or you can fast motion. The most important, very popular, is the line trajectory, arc, circle, or helical. Our circle trajectory not only in 2D, it also provides 3D. And we also provide a lot of API in the machine. You need to set your mechanical parameter, your system, something else. And we also some advanced. You maybe your machine will blend in, you will do velocity very smooth, or checking override speed. And you also maybe have a DA module or AD, you have some sensor want to into your system, your controller. All very soon we provide lots of good and API to integrate your controller. Maybe in the future in a robot, something else. Okay, so now you can know we provide the hardware and our software and zero. And the one is another project I told is ISACAT. It's a digital control. Okay. In our user, the most part is about a robotic control. Okay. We also to accumulate our experiment about any kind of controller, but in around recent 10 years, the robot control is most popular. And most important is the Internet Server Protocol. Okay, it's the ISACAT protocol. So we cooperate with a German accountants. It's a third party. So we have our ISACAT ECM. After that, in the motion control, the most popular and the most important is the real-time operating system. Our solution have our RTS is a very stable version, stable product, and it's also used in industry now. But around the world, in the industry 4.0, we can to integrate with some industry Ethernet protocol, something OPC UA or IO-Link, CC-Link, and something else. We can integrate it is ITRI motion controller. And in the driver, in the slave, you can see the servo driver. But this one is different with the traditional, is just only pulse over the velocity. Here is the ISACAT protocol servo driver. Maybe some I/O, ADDA module, machine bridging, something else. In the upper side, you can see the industry Ethernet protocol, maybe UI, ERP. The most important, around the world, our research is about big data or artificial intelligence. But you use the ISACAT mesh controller, you can easier to meet what you need. You can capture over producer over the data, what you want, maybe the velocity, encoder, something else, information. After that, you can do research and develop the AI algorithm. And in the ISACAT motion controller, we have maybe more than thousands set was in the production line application. So it's also can to meet now around the world industry 4.0's need. So this is a new generation of our controller. Final, we let you know any kind of a field, any kind of a machine. If you have a user motor or a servo motor, you can use our multi-access motion control solutions. Maybe something like a traditional CNC, gantry controller, or here is a touch panel controller, any kind of a machine. If you have a motor, you can cooperate or to integrate our solution. And here, around 10 years, the most popular and big amount is the 6S architectural robot, because we tend to instead of human labor. And Scala, Delta, any kind of a robot. Maybe previous session, we also have to describe about robot control. But here, we will focus on motion control kernel. we will here will let you know. And here is some interesting, okay, interesting result will show you. We also focus on the robot control. By this project, we finish with integrate with the virtual reality. In the right side, you can see here is the virtual robot. In the left up side, you can see a physical robot. You can left down, you can see a human. You just like play a game, you can do automatically to generate the robotic trajectory to finish the robot control. In the traditional, you don't need to coding, maybe the software engineering is not easy to finish it. The most important, you can avoid very dangerous and very hard environment. Something like a painting, polish, something else. So this project will integrate the virtual reality. If you have any issue, we can contact me. And the next example just to show you. And this project we integrate with the robot control, also use our EMPS kernel. And we to integrate our machine vision to separate different kind of garbage to the same. This is something like this one. Environment is not very clear. So we use a robot integrate the machine vision to finish to solve this question. This also you just finished last years. Also to let you know. The most important, we have our cooperated around the world. You can see the left column is this one, German, Beckhoff, and ESA-CAD. We cooperate with the account is the third party. We also the Switzerland, ITRI, the academic organization. In our virtual reality robot control, we cooperate with the ITRI. And we also have, just as I told, the semiconductor application, SRM, GPM in Taiwan, this is Malaysia. Also, we have lots of cooperators, the academic organization over in the industry. And after this meeting, I wish we can have a next step to close to cooperate with all of you guys. If you have any question, you can contact me. Thank you.